Okay, this video I'm going to be solving systems of inequalities this time. So there will be multiple solutions based on shading. Okay, so you're going to graph each inequality, you're going to shade each one. Remember, if it has a little line underneath, it's a solid line. If it doesn't have the line underneath, it's a dashed line that kind of represents an open dot in most situations. Use a test point to figure out what side to shade. So the easiest test point is going to be 0, 0. To figure out where it's shading, our overlapping section is going to be the section that is our solutions. Okay, so my first one, we got to get it into y equals mx plus b. So let's subtract 4x. So I get 3y minus 4x plus 12. Divide everything by 3. So I've got y is greater than negative 4/3 x plus 4. So he's starting at 4. 1, 2, 3, 4. And he is moving down 4. 1, 2, 3, 4. To keep him negative, we need to go right 3. Or I could go up 1, 2, 3, 4, left 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, I checked to see if it's a solid or dashed line. It doesn't have the line underneath, so it's going to be a dashed line to show that it's got some open dots in it. Okay, when I do my shading, I plug in the point 0, 0 as long as it's not sitting on that line. So I'm going to plug him in to see if it's true or not, because we shade where it is true. So I know that all of those points work. So I've got 0 is greater than, that's going to be 0 plus 4, so 4. I am not eating the bigger number. So if it is not true, I need to shade on the opposite side that 0, 0 sits on. So I'm going to shade on this side here. Okay, now we're going to switch colors here. I'm going to erase my 0, 0 point. Alright, so I need to add x, divide everything by 2. So I got y is greater than or equal to x over 2 minus 1/2. So he starts at negative 1/2, and he goes up 1, right 2, 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 or down 1, left 2. And then he is a solid line because he has the line underneath in his inequality. Since it doesn't run through my 0, 0, that can be my test point. So he's sitting in that origin there. 0 divided by 2 is 0. Minus 1/2 is just negative 1/2. I am eating the bigger number, so it is true. So I can shade across my 0, 0 this time. So I'm going to get my highlighter and shade above it. Okay, so my solution section then is all of this. So all of those points, if I plug them into those two equations, it would be true for both of them. Okay, my next one, we got to subtract x, divide everything by 2. So it's like similar to what we just did. So I start at 1/2, I go up 1, left 2, because it's a decreasing line this time, or down 1, right 2. I look up, it is a dashed line because it doesn't have a line underneath it. I can do 0, 0 as my test point because there's nothing running through it. This gets me 0 plus 1/2, so 1/2. I am not eating the bigger number, so I need to shade above it this time. Not across that 0, 0. Okay, my next one's a circle. I square root to get the radius. So he starts at 0, 0, and I go out 5 every direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is a solid line because it's got the line underneath. I could plug in 0, 0, so 0 squared plus 0 squared less than or equal to 25. So 0 is less than or equal to 25, which is true. Since 0, 0 is in the inside of my circle, I'm actually shading everything on the inside. Okay, so your double shaded region is right here in that circle. Okay, so this starts at negative 3, 4. It does 1, 3, 5 to the right. So up 1, right 1, up 1, right 1, 2, 3, up 1, right 1, 2, 3, 4, 5. It is a solid line. It's got the line underneath. I could plug in 0, 0. So that's going to be the square root of 3 plus 4, which is automatically going to be bigger than 0, so I can shade downward towards that 0, 0 line. So I'm going to shade all of this as far over past that point there. I don't want to go to the left of that point because that's not going to be part of my line, so I got to stop at that point there. Okay, my next one's a line, so let's change colors. So he starts at 7, and then he goes down to 1, 2, 3, 4, 5, 6, 7. Down to the right one, or up to the left one to make him negative. And he is a dashed line. Can plug in 0, 0 since it's not sitting on that 0, 0 line. Okay, that is not true. I'm not eating the bigger number, so I need to make sure I shade away from that 0, 0. So I'm going to shade everything above it. So your double shaded region is right in here. Okay, my next one, we have a parabola starting at 0, 0, 1, 3, 5 up. So right one up 1, right one up 1, 2, 3, right one up 1, 2, 3, 4, 5, left one up 1, left one up 1, 2, 3, left one up 1, 2, 3, 4, 5, and then it is a solid line. We cannot plug in 0, 0 this time because my line sits on it. I wouldn't know if it was true what way to shade, the top of it or the bottom of it. So I need to pick a different point. So I could pick the point 1, 2. When I pick a different point, I want to make sure I label X and Y so I plug them into the right spots. So I've got 2 is greater than or equal to 1 squared. Well, 1 squared is 1. I am eating the bigger number. So 1, 2 set right here. And it's true, so I shade everything on the inside of my parabola. Whee! Alright, my next one here is a line starting at 2. It's just got a negative slope, so just going down and up. And it is a dashed line. I could plug in 0, 0. So I'd be getting 0 is greater than 2, which is not true, so I need to shade above my purple line so that I do not cross my 0, 0. Okay, so my double shaded region in this one is going to be inside my parabola, excluding that part down there. Alright, my next one, we got 2 lines. So let's graph the bottom one first since he's already solved. So I start at 1 and then I go down to the right one to keep him negative, or up to the left one. He will be a dashed line. We can plug in 0, 0. So I'd get 0 is less than 1, which is true, so I can shade below him. Whee! Alright, next one I gotta solve a little. So I'm going to add x to both sides. Divide by 3. So I gotta start it at 2/3, and then I need to go up 1 to the right 3. Or down 1 to the left 1, 2, 3. He is going to be a solid line. It's pretty close to 0, 0, but it does not hit there, so I can go ahead and solve it. I'm going to solve it from the original. So just in case I mess up on my math. So I basically have 0 on that left side. And I'm not eating the bigger number, so I need to shade above my green line. So my double shaded region is going to be that top left section there. Okay, my next one starts at 0, -4. It does 1, 7, 19, up. 0, 1, 2, 3, 4. So right one, up 1, right one, up 1, 2, 3, 4, 5, 6, 7. And it is a dashed line. Left one, down 1, left one, down 1, 2, 3, 4, 5, 6, 7. Plug in 0, 0. So I would get this here, which is true, so I can shade to the left of him to cover that 0, 0. Okay, and my next one here, it starts at 2, 0. Absolute value is 1, 1, 1, up. So 2, 0. So right one, up 1. Left one, up 1. And solid. Plugging in 0, 0. I would get an absolute value of -2. Absolute value bars always make things positive, so that would actually pop to be a positive 2. You could double check it by typing it in your calculator using the ABS button. That is not true, so I need to make sure I don't shade across that 0, 0, so I'm shading everything on the inside of my V this time. So my double shaded region is like in this left corner here, right there. Okay, now we're writing equations based on it. So these are both lines. So for lines, you always want to figure out where it's crossing your y-axis at and your slope. So it looks like it's crossing at -1 here for this one. So we'll call this my red one here. So it's crossing at -1, and then we need our slope. So if I pick that one and I go to this one, it looks like it's going up 3 to the right 1. So 3 over 1 would get me a 3, and then I got to figure out its inequality. So it looks like it's shading this way. So my 0, 0, if I plugged it in, should not be true. So when I plug in my 0, 0, 3 times 0 is 0 minus 1. I need to make this not true, so I need to be eating that 0, and it's a dashed line, so I need to make sure I don't put a line underneath it. Okay, my next one here, we're going to do the pink. It looks like he's crossing at 1. And then my slope, let's say I go from this one to this one, it goes up 1 to the right, or to the left 4. So up 1, left 4 is a negative, so it's a -1/4, and he is shading up, which means it's not crossing my 0, 0 again. So I need this not to be true when I plug in 0, 0. So not be true, I need to eat the 0, and it's a solid line. So it should be facing this way. Okay, my next one, we have a circle, so let's find its center here. 1, 2, 3, 4, 0. So my center is 4, 0. My radius is 1, 2, 3. So I've got x minus 4 squared plus y minus 0 squared is just y squared. And then 3 squared will get me a 9 here. Okay, it's colored in on the inside of the circle, so when I plug in 0, 0, I need to make it not true again, because it's not crossing that 0, 0. Okay, so this will get me a -4 squared, which will get me a 16 plus 0, which is just a 16. To make it not true, I need to eat that 9, and it is a solid line. So my inequality is going to be eating that 9. Okay, then I have my square root here. So its shooting star starts at -2, -3. So I've got y square root of x plus 2 minus 3. Okay, it's shading this way, so not crossing my 0, 0 again. So I've got 0, we don't know what we're filling in here, 0 plus 2 minus 3. It's not true again, so I need to make this not true. So that means I need to eat the 0, eat the y, and it is a dashed line. So there's my other answer. Oh wait, square root of 2 minus 3 is a negative, so I actually need my inequality going the other way, this way. Because when you type this in, it gets you a negative, so you need to be eating that negative number. Alright, Jess makes $10 an hour cutting hair, $12 an hour doing manicures. She cannot work more than 15 hours per week. Graph the two inequalities that Jess can use to determine how many hours she needs to work at each job if she wants to earn at least $120 per week. So let's make cutting hair X and manicures Y. Okay, so the total amount of hours is 15. So X plus Y is 15, and we can't do, she cannot work more than that. So she can work 15, she just can't work more than that. Okay, and then the money with the money. So 10x plus 12y and 120, and it says she wants to earn at least that. So she's needs to be eating the other side. She can be making 120, but she needs more than 120. Okay, so the least amount is 120. That's why we have to eat the other side, because it should be smaller on the other one. Okay, and then we're going to have to graph this. So this one will be the easier one, so we could subtract x and get negative x plus 15. Let's go, I guess we could do 1, 2, 3, 4, 7, 8, 9, 10. Alright, so it starts at 15. And it would go down one, right one. So here is my first one, and it's going to be a solid line. Then we got to figure out what side to shade. So if I plug in 0, 0 to this, it is true. So I would be shading downward. Let's see if I can get it. Now my other one, we have to do more solving. Not yellow. So subtracting 10x. Plus 120, divide by 12. So this would simplify, both of them are divisible by 2, and that gets me 10. So he starts at 10. Down 5, 1, 2, 3, 4, 5, right 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Solid line. When I plug in 0, 0, it's going to be shading above it. Okay, so the hours that she can work is going to sit right in here. So any of those points will work for her getting the amount of money that she needs and within the time frame of it. My next one, the Mary Bakers are baking pumpkin bread and Swedish soda bread for this week's special. They have 24 cups of flour and 26 teaspoons of baking powder. Graph the inequalities that represent how many loaves of each type of bread bakers can make. List 3 different types of combinations of breads they can bake. Which combination uses all the available flour and baking soda? Okay. So there is actually a picture right here that we're going to have to use. So this is going to be my X and my Y. So matching flour with flour, I'm going to get 2x plus 1.5x. And then the total flour was 24. And it says they have it, so it's going to be equals 24. Now my y, I've got 1y plus 2.5y, and that total in the directions said 26. So we're going to have to get these in forms where we can graph them here. So if I take this one, I would be definitely messed this up. Sorry, you don't want x's and x's in the same thing, because you can do what I just did and you're not able to graph it. So I'm going to erase this super fast. Alright, so we're going to match the flour and the baking soda here. So I've got 2x plus 1.5y. So that's matching these two like I was doing, but that was supposed to be my y. I messed up and put x there. Is equaling that 24. And then my other one is 1x plus 2.5y is equaling 26. Alright, now we can actually graph it. So we're going to subtract 2x divide by 1.5. So I'm going to get y is equal to -4/3 x plus 16. So that's one of them. Solving the other one, we subtract x. Divide by 2.5. So I get y is equal to -2/5 x plus 10.4. Alright, so starting at my pink one, or I guess we could start with my yellow one. You'd be starting at 10.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.4. You'd be going down 2, right 5, down 2, 1, 2, right 1, 2, 3, 4, 5. Okay, my pink one. Starting at 16, down 4, right 3. So 10. And I said down 4, right 3. 1, 2, 3, 4. Okay, so which combination uses all the available flour and baking soda? It's going to be that point right there, which is 8, 6. Okay, and remember your X stood for your flour, and then your 6 or your Y stands for your baking soda.